Hello again and welcome back to our course on Excel 2013. In this section we're going to start to look at financial functions in Excel 2013, and we're going to do this via a case study. The case study we're going to use involves looking at the options for a mortgage, and in the first section we're going to look at the financial functions themselves and how some of those are involved in costing a mortgage, and then subsequently we're going to look at developing the case study and also using some what-if analysis. Now the first thing I'm going to do is to set up the values that are going to be used in the calculation of mortgage payments. The first of them is going to be the amount of the loan, which I am going to at the moment treat as the purchase price of a house. So I'm going to enter a purchase price. The next thing I'm going to need to enter is the interest rate. Now clearly interest rates can vary, although when somebody gets a mortgage they sometimes get a fixed interest rate, sometimes a variable interest rate. I'm going to treat this as a fixed interest rate for the moment. The next thing to enter is the period of the loan, the duration of the loan. Now I'm going to put the duration in years. And then how many payments per year are we going to make? Now given those four things, I'll put the numbers in just a moment, what we need to do is to work out the amount of each of those payments. And one of Excel's financial functions does that job for us. So first of all, let's put in a price, an amount of a loan. Let's say we're going to have a loan of $300,000. Now let's put in an interest rate. Let's say the interest rate is going to be 4%. The duration in years, let's go for a duration of 30 years. And let's say we're going to go for monthly payments. Now what I'm going to do is to just tidy this up a bit before I do the calculation of the monthly amount. So I'm going to select that row with the headings in it, bold, center aligned, and then with each of these I'm going to go in and format the cell accordingly. So 300,000, format cells, that's going to be currency, 2 decimal places, although in this amount I actually don't need any decimal places. That's fine. The interest rate I will treat as a percentage. Watch what happens if I just click 4 and then say format cells and change it to percentage. It actually becomes 400, because what it does when I change that is it says 4 units is 400%. So what I really want to do here, I can either go back and make that 0.04 to start with, or I can change this to just say 4%. It's a common thing that happens when you're working with percentages. If you forget what happens when you convert a number to percentage, but you can just go in and edit it like that. The duration in years 30 is fine. Payments for year 12 is also fine. So let's work out what that payment is. The function that you need here is one that you'll probably use quite a bit if you use financial functions extensively, and it's the PMT function, PMT for payment. Go to the Formulas tab on the ribbon and there is a category in the function library of financial. Click on financial. There are a lot of financial functions. If you scroll down, click on PMT, and this comes up with a function arguments dialog. Now there are up to 5 things to enter here, and as you click in each one there's a little explanation of what to enter in each case. This is really a common theme amongst the functions, and it can be particularly useful with financial functions where Excel tends to use the standard abbreviations for financial entities, but to the layman some of those abbreviations may not really mean very much, so having an explanation as well is really useful. So let's look at what the arguments are for the PMT function, starting at the top. And the one at the top is rate. And the explanation of that is the interest rate per period for the loan. For example, use 6% divided by 4 for quarterly payments at 6%. Now in our case, our interest rate is 4% in a year. Therefore, in a period, it will be 4% divided by 12. Now, we're not going to put in there 4% divided by 12 because that would fix this. It's going to make it more difficult for us to make any changes to either the interest rate or the payment method that we're going to use. So what we've put in here is C3 divided by E3. So that will be 4% divided by 12, and again it's a common thing with these function arguments dialogues. Usually, depending on the row or the particular case that you're dealing with, Excel will do the calculation for you. So this is saying that in 1 month, bear in mind we're doing 12 payments a year, in 1 calendar month we're going to be paying 0.00333333% interest. So let's look at the second amount. N per is the total number of payments for the loan. Now we're going for 30 years in this case, 12 payments per year. So the total number of payments will be D3 times E3. 360 payments. The next field is PV. PV is the present value, the total amount that a series of future payments is worth now. And this basically means what is the amount of the loan, which is going to be, of course, B3. Now, a very important one here, FV. FV is the future value or a cash balance you want to attain after the last payment is made. 0 if omitted. There are some types of loan where you're not actually aiming to pay off the full amount, you're just aiming to reduce it. In this case we're going to pay off the full amount, but if we just wanted to reduce it to a closing balance, we could put the closing balance in here. If we omit to put a figure in here, then it's assumed that the closing balance is going to be 0. And the final value to put in here is the type of payment. Now, this is a logical value. You either put in a 1 or a 0. If you put in a 1, then you're assuming that payments will be made at the beginning of each payment period. If you put a 0 or omit a value here, then it's assumed that payments will be made at the end of each period. Now we're going to make payments at the end of what are currently monthly periods here, so we can omit that. I'll put a 0. So, having completed everything we need to in the function arguments dialog, click on OK and see what happens. And what we come up with is a red figure, so it's a negative amount. That means that it's a payment, a debit from an account rather than a credit to an account, of $1,432.25 per month on this loan. So that looks really great. It gives us a very simple way of calculating the payment amount. Now let's suppose we looked at that and thought, okay, well, I wonder if I could pay it off a little more quickly than that. Could I afford a little more than that per month? What if I paid it off over a shorter period? Now, one of the advantages of what you've learned already, and one of the advantages of how functions and formulae work in Excel 2013, is that it's pretty easy to experiment with this. I could just put a different amount of years in there. I could put in more or less payments per year. Let's suppose, to begin with, that I just select those cells and then drag down, just say a few rows like that. And then I do a fill down. So on the Home tab, down, Control D is the keyboard shortcut, you should remember, so Control D. And now let me try some different numbers of years. So I've got 30 there. What would the payment be with, say, 40 years? I might not be able to get a loan for 40 years, but what effect would 40 years have? So 10 more years, what difference would that make to my monthly payments? Well, it would knock them down by about $180 per month. What about 25 years? They're up to 1583. 20 years? 15 years, 10 years, 5 years. And you can compare all of the payment amounts and say, well, which of those could I afford? Maybe you can say, I could actually get it down to 20 years instead of 30 by paying $1817.94 per month. So that's less than $400 extra per month. I could reduce the loan term by 10 years. So that shows you how easy it is to experiment with these figures once you're using the PMT function. Now, one of the great strengths of being able to do this sort of thing in Excel 2013 is that there are many other financial functions that can help with an analysis like this one. So if I were looking at the options in terms of duration, I may ask a number of questions about those options. For instance, one of the questions might be, well, with each of these options, what would I actually finish up paying in total? And there are a few functions that can help with this. What we're going to do, just as an example, is to look at a function that tells us the total amount paid over the period of the loan. And that's basically made up of two things. It's made up of the repayment of the capital, the purchase price of the house in this case, plus the interest. So what I'm going to do here is to show you how to put in the total interest paid. So I'm going to introduce a new column there. It's the total interest column. I could obviously then add the total interest to the capital repaid to find the total amount of money I would have paid altogether. Maybe put that in column H. But let's start here with the total interest. There is a function, cum-I payment, which is cumulative interest payment. Quite easy to insert that. So again, financial, cum-I payment, there it is. We're going to fill in the arguments for this. One thing to be careful of here, sometimes when you get the function arguments dialog, you see a little scroll bar over the right. That means there may be more arguments than you can see when you open it. So in this case, don't miss that last argument, whatever you do. There are a couple of others like that as well. So first of all, we put in the rate per period, which of course in our case is C3. That's the annual rate divided by payments per year, which is E3. Next is N per, the total number of payment periods, which is D3 multiplied by E3. PV next, the present value, that's the amount of the loan, which is B3. The start period. Now, we can find the total interest paid between any two periods. We're here going to look at the total, so we're going from period 1 to the last period. So we put 1 in the start period, and the end period will also be D3 multiplied by E3 because it's the total number of payment periods. Don't forget, Excel's just calculating these as we go. 360 payments, 30 years, 12 per year, that's 360, that's fine. And then finally the type, we discussed the type just now. 1 if you're paying at the beginning of a period, 0 at the end. Unfortunately, there's a little inconsistency here in that in this dialog for this function it doesn't default to 0, so we actually have to put a 0 in. So when we've done that, click on OK, and what we find is that if we use the 30-year duration and monthly payments, the total amount of interest paid would be $215,608, which means add it to the 300,000, which of course we could do here, you'd pay just over $515,000 to pay off a $300,000 loan. So let me just format that as currency. And in this case I'm going to use red for the payments, 2 decimal places, and then finally with this I'm now going to fill that down to compare the total interest paid with all of those other durations. So fill down, that's Control D, and there you can see, for instance, in the case of the 5-year term, Obviously the monthly payments are very high, over $5,500 per month, but the total amount of interest paid is relatively small at $31,000. The figures in the middle are probably more like the ones where I'd want to look at those and say, well, which one do I think gives me the best deal? So I think even from that relatively straightforward example, you can see the power of financial functions within Excel. But there's an issue with this, and that is, if I were being very, very realistic about a mortgage loan like this one, I would then say, okay, that's fine if interest rates are 4%. But what happens if interest rates go up during the period of the loan? If I'm not on a fixed interest rate, how would increasing interest rates affect my payments? Would the loan still be affordable? And again, I might say, well, what if interest rates come down? Maybe I could pay this off more quickly. So it's quite often the case that the particular financial issue you're dealing with is a little bit more complicated than just changing one variable, in this case the duration. So we're going to look at a slightly more sophisticated version of this analysis in the next section. Please join me for that.